Okay, so now we are going to learn about the design process, right? This is our new topic, the design process. So descriptions of design process we are going to see first. So what happened? Maurice Asimow was among the first to give a detailed descriptions of the complete design process, right? And where he has given this design process definition in the morphology of design, right? So he proposed 7 phases of designs, right? And these 7 phases are we are going to see in the coming slide. So in the next slide you will see that various activities are there, like the first phase of design is there, which is known as conceptual design. The second phase of the design is there, which is known as embodiment design, and the third phase of the design is there, which is known as detailed design, right? So this 8-step set of design activities is our representation of the basic design process. Okay, so the purpose of this graphic is to remind you of the logical sequence of the activities that leads from the problem definition to the detailed design, right? So here we are going to see like this what are the different phases of the design processes, right? So the phase 1 is conceptual design, phase 2 is embodiment design, phase 3 is detailed design, then phase 4 is planning for manufacture, phase 5 is planning for distribution, phase 6 for planning for use, phase 7 for planning for retirement of the product. Okay, so here you are going to see like what happened. You can see this is your conceptual design. This is the phase 1, right? Conceptual design is categorized into 4 steps: defining the problem, gather the information, concept generation and evaluation, and select the concept, right? So this phase confines into the name of the conceptual design. Okay, then once you are done with the conceptual design phase, you have to move ahead with the next step, which is known as embodiment design. Embodiment design basically categorized into 3 steps, right? So the first step is finalization of product architecture, the second step is the configuration design, and the third step is parametric design. Okay, and then this is your first conceptual design phase, this is the second embodiment design, and the third one is detailed design phase, where we are going to cross check the complete design once again, right? And the point to be remembered that embodiment design is also called as preliminary design or system level design. So there are basically 3 names, or in totality there are 3 names: embodiment design, preliminary design and system level design. Okay, so we are going to see all these steps in the detail, right? So here you can see I have taken some example. What are these? These are some concepts, future concept of various products from various companies, right? This is an example of iWatch, right? Then here you can see this is one car. Okay, this is the example of concept car, right? Then here you can see the Renault Ease Go concept car. Okay, so why they are showing these concepts? So that they are just showing you the company's strategy that they are working on the concept development, right? So one more example, right? You can see different cars are there, and all these are the concepts car, right? So now we are going to see the phases of product design and development. One by one we'll see. So we will start with the phase 1, that is the conceptual design, right? So basically what is happening when we are talking about conceptual design, we must be a creative person, because now you have to involve your creativity, because you have to generate many possible solution, right, in the conceptual design. So here the point is that conceptual design is the phase that requires the greatest creativity. It involves the most uncertainty and requires coordination among many functions in the business organization. Why we are talking about uncertainty? Because here either you are going to finalize the concept or you are going to leave it as it is, right? And you need to coordinate with the other departments as well, right? So identification of the customer need is the first step. Okay, so what you have to do here, you have to understand the customer and customers need. Because suppose if customer is saying I want to have this particular mobile phone, right? So what is the need here? Mobile phone with the particular specification. Those are the needs of the customer, right? Once you know that customer needs is this particular item, okay, then you must define the problem, right? Like here you will be going with the next step, that is the problem definition. So the goal of this activity is to create a statement that describes what has to be accomplished, right? Accomplished means based upon the needs you are going to create the statement, okay. And why we are doing this thing? To satisfy the need of the customer, right? So this involves analysis of competitive products, means you will be checking the existing products, right? Then you are going to set the target specification, then you are going to list out the constraints. Constraint means your limitations, okay, than the trade-offs, okay. So ultimately QFD, that is the quality function deployment, is going to be the part of your product design specification here in the conceptual design, right? So in phase 1 of the conceptual design, what we are going to do, we are going to gather the information, right? So gather the information means what? You can have the information from various points, like internet is the source of medium where you can have the information. You can go through with the journal, conference paper, right? Some magazines are there. You just gather the information about the existing product, right? That is the second step. Now comes to the next step, that is the conceptualization. So what you are going to do here, concept generation involves creating a broad set of concepts means how, what you are going to do here, you are going to create many sets of concepts, right? Like if you want to develop a mobile phone, what you will do, you will try to just think about 4 or 5 types of design with your team, right? Broad set of concepts that potentially satisfy the problem statement, right? Team based creativity methods combined with efficient information gathering are the key activities, right? A single person can give only small contribution, but when it comes to the team, they can give better contribution, okay. Then once you are done with the conceptualization, you can go ahead with the next part, that is concept selection. So now you are having set of concepts. Suppose if you are having 10 or 12 concepts, what you can do, you can select one concept, okay, from that from those concepts, and you just go ahead with the manufacturing as well as the next step, right? So here what you are going to do, next step, you are going to refine the product design specification, right? Product design specification. So the product design specification is revisited after the concept has been selected. Means if you have finalized the concept of mobile phone, now you will try to give the specification. Then you are going to deal with this type of parameters. What are those parameters? Critical to quality, means based upon your objective you are going to create some critical to quality parameters, okay. Then you are going to consider the refinement of product design specification, okay. Once you are done with the refinement of the product design specification, you will move towards the next step, that is design review, okay. So before committing funds to move to the next design phase, a design review will be held. Means you are going to have a meeting with your team, right? Here you are going to finalize the complete schedule, as well as you will check what amount of funds I have to allocate for this particular steps, okay. So this is the design review. Now here you can see, right? Here the first step, what you have to do, you have to clarify the problem. You identified the problem with the user, like what they want. Okay, then what is happening, you are just going ahead with the next step, that is search externally or search internally. Means what, like if you want to design a mobile phone, right, what you will do, you will check externally like what are the existing designs of the mobiles are available, right, and you will check internally with your team as well, right. Externally, when you are going to check externally, you can talk with the lead user, you can check with the experts, you can check patents, literature, benchmarking, internet. Okay, from here you will see what are the existing products are there. Okay, then once you have checked internally, oh sorry, externally, then you will check it internally, and here you will try to identify what is the capacity as well as capability of your team, right. So here what you did, here you just try to identify the existing concept as well as the new concept from your team. So now you are having the various options with you, right. So suppose I am considering, if you are having 15 options, whether it's existing or new concept, what you will do, here you will explore systematically by using classification tree or combination table. Here you will try to analyze all these 15 concept, and what you will do, you will select one concept, and remaining 14 options you are going to keep it with you, right. You are not going to dispose this off, right. These may be useful for the future, right. So one concept you will select, and accordingly you can go ahead with the process, right. So there are many concept generation techniques are there, right, by which you can generate the concept, right. So the first method is brainstorming, right. You can sit with your team, okay, and you just think about the particular topic, then you just try to develop various concept, right. You can go ahead with the prototyping, okay, the pilot testing is also there, then survey is there, then ideathon, as well as axiomatic and simulation process. So these are the process by which we can generate the concepts, okay. So we will see all this process in the coming lectures as well, okay. Now once we are done with the first phase of the conceptualization, we are with one concept now. Now we are entering into the second phase, that is embodiment design. So ultimately what we are going to do, we have talked about the conceptual. So ultimately what we can say, we have finalized the skeleton. Now we are going to put the flesh on the skeleton, right. Okay, so here an embodiment of all the main function that must be performed by the product must be undertaken, right. So it is one of the most important step. It is in this design phase what we are going to do, decisions are made on the strength, okay, then material selection, size, shape, and spatial compatibility, right. So ultimately you are going to take some decision to just outcome or to just overcome with the designing constraints, right. So ultimately what you are going to do, you are going to finalize the preliminary design, okay. So beyond this design phase, major changes become very expensive, right, because this phase embodiment design is also known as preliminary design phase, right. So here when we are talking about preliminary design, you can perform all the design in a detailed manner, because once you have the detailed design phase, after that the changes will be very difficult, okay, right. So preliminary design we already discussed. So basically embodiment design phase is categorized into three categories: product architecture, configuration design, and parametric design. Okay, so what is product architecture? So here basically there are two types of product architecture. Maybe we can say the first type of product architecture is modular design, or the second one is integral design. Ultimately what is this product architecture? How you are placing the system of that particular product. Like if we are having the mobile phone example, where the battery is going to be, right, where the camera you are going to install, where the chipsets, right, motherboard, right. So these are the subsystems or module. Okay, so you must know the arrangement of the product architecture. Okay, so here we are going to see in the detail, right. So in the product architecture we have finalized whether the product is going to be modular or integral. Okay, then once we have finalized the product architecture, we will be moving ahead with the next step, that is the configuration design. Okay, so here you are going to talk about some kind of holes, ribs, splines, curves, right. Like if you are using any kind of system, okay, or if you want to design any product, what you can do, you can check whether there is some standard components are required, some kind of special components are required. Okay, there are some assemblies are there, sub assemblies are there. So that part we are going to finalize into configuration design. Okay, suppose if someone is asking to you, what is the configuration of your mobile? Okay, so what we are saying, like sir, 5.5 inch screen, okay, 4 GB RAM, right, then 128 GB of ROM capacity. These type of specifications we are giving, right. So this is what, these are nothing but the configuration means you are just giving the specification of the component and naming it. Okay, so in the configuration design we are finalizing all this sort of detail, right. And when it comes to the third phase of the embodiment design, that is the parametric design. Okay, parametric design is what, basically parametric design is associated with the design variables. Like if you're designing mobile phone, so that mobile phone will be having some kind of dimensions, some kind of tolerances, some kind of weight, height, length, right. So we are finalizing all the parameters of design in this third phase, which is known as parametric design. Okay, so here parametric design also deals with the aspects of the design that could lead to failure, right. So ultimately you have to check all the parameters, right. Ultimately what you want to do, you want to have a successful product, so you must finalize each and every component in a proper manner. Okay, so parametric design is over here. Now comes to the third phase.